evening. Thank you all for coming. Apologies for the somewhat awkward position of me to, it's necessary in order for me to speak in the microphone. Later tonight I will not speak in the microphone. It's great to see that you came. Tonight we will speak about decolonizing science and mathematics. The event is organized by, I have a couple of abbreviations, all with a C. The UOC, the NUC, and CC, which stand for the University of Color, the New Urban Collective, and Critical Collective. I will speak more about these groups later tonight. We will speak about decolonizing science with a focus on mathematics, and I know for a fact that many decolonizers don't know much about mathematics, so it's a good thing that you get your priorities straight tonight. It's a very relevant topic, and our speaker will also explain the relevance and the importance of this subject. The speaker is Chandrakant Raju. Many know him as CK Raju with the beautiful bottle of water. You will see that in a bit. He is also known for being a professor of mathematics, a renowned professor of mathematics. He has lectured at universities across the globe. Professor Raju has contributed to the first Indian supercomputer, and he is involved in the project of the history of Indian science, philosophy, and culture. This project has produced 100 volumes. You said that your volume was the 50th of those 100. Professor Raju will speak for about 45 minutes, then we will break briefly, and after the break there is room for your contributions, which means questions, answers, and any points of discussion that you would like to raise. The Q&A session will also take about 45 minutes, maybe 1 hour, we see how it goes. And we will end the evening somewhere between 9:15 and 9:30. In a bit, we will spread an email list throughout the audience. You can sign up to these emails, to this email list, if you would like to stay updated about future activities of the UOC, the NUC, and the CC. You will receive emails from them if you sign up. Now, without further ado, I would like to give the floor to Professor C.K. Raju. Please give him a very warm welcome.
Thank you very much for inviting me, and I'm very happy to see so many young faces. So it is really a pleasure. So let me start with this business of decolonizing mathematics. I'm sure all of you must be wondering, what is this decolonization of mathematics? How do you do it? Everybody has this question, what is there to decolonize? 1 plus 1 is 2. What are you going to make it? 3. Right? This is the stock question that gets asked. So simple. And you can show, so let's say 1 piece of paper and 1 other piece of paper makes 2 pieces of paper. You can see it. Please remember that. And what is a piece of paper is a bit arbitrary. I don't know if I can tear this up. But if I could tear it up, and can I tear this up? You don't need it? Something about alcohol. So I don't know how many pieces of paper do I have. So now I have 3 pieces of paper. Right? There is a problem. But there is a more fundamental problem. So I have no problem with your doing this empirically. That is what I advocate. Alright? This is part of pre-colonial mathematics, and that is what I advocate. As decolonized math, I would like to restore it. So what is colonial math? And that is what you need to learn. Also called formal mathematics, which began in the 20th century, more or less, created by David Hilbert, Bertrand Russell, and so on. Now Russell and Whitehead in their Principia, they take 378 pages to prove 1 plus 1 equal to 2. 378 pages, and here is the 378 pages. Now maybe I can just amplify it for you. Do you understand one line or one word in this? This is 1 plus 1 equal to 2. 378 pages of what? Gibberish? What do you call it? So this is the problem. It's not like one piece of paper and one piece of paper, that is common sense, no problem. But this is not common sense. Almost nobody knows it. If you ask your professors of mathematics, they won't know, they would not have studied this. Most of them would not be able to explain. So, this is the idea that if you are looking at 1 plus 1 equal to 2, it's not as simple as just saying one dog and one dog make two dogs. Because that you are seeing something. Okay, and why did these people need 378 pages? Any guesses? What is so complicated about 1 plus 1 equal to 2 that it needs 378 pages? So the question then is this: are you prepared to accept that what Russell, the Nobel Prize winner, wrote is complete nonsense, it's gibberish, throw it in the dustbin? That's the question. It's very hard to do that because there are so many structures of authority tied to him. Comes from Cambridge, as a professor, wrote this, and so on. But it doesn't make sense to you. You believe it on the strength of authority. Okay, so this is what we want to demand, that this formal mathematics must be thrown out of the university syllabus. Doesn't make sense to you, doesn't make sense to lots of people, and doesn't contribute anything to practical value of mathematics. So let's leave that page. I think the answer is no. If somebody wants to say yes, I'm open for discussion. Right now. Okay. So this is an example, of how colonial education teaches ignorance. You're all in the university, you don't know why 1 plus 1 equal to 2. Isn't it a shame? What sort of education did you have? Which didn't teach you why 1 plus 1 equal to 2? So I think that this is something very strange. We need to understand why you are being taught ignorance, and this is also an example of how colonial education teaches superstition. You're taught ignorance and you're taught superstition. So what's the superstition? Well, there are a number of superstitions. You believe that math is universal, don't you? You say 1 plus 1 is equal to 2, how can it be something different? You believe in the universality of math. Actually, you believe in the universality of perception or something empirical. But you believe that. And then the question naturally arises, simple common sense. Look, Egyptians did mathematics long back, Rhind papyrus. Indians did mathematics in the Shulba Sutra. Why isn't that universal? So if math is universal, that should also be universal. So teach that. Why do you teach what Russell did? That was not universal. That did not exist before the 20th century. So why not teach that? So that's the question that you need to answer. And well, Indian Shulba Sutra already mentioned that. So you don't, the thing to understand is that the purported universality of mathematics is a normative universality. It says that the math that is done is superior. It ought to be the norm. Okay, the Western way of doing mathematics is declared to be superior. Just as the white race is declared to be superior. It's declared that you ought to follow it. Right? So the pre-colonial ways of doing mathematics, what Egypt did, what India did, what everybody else did, is declared to be inferior. And that's the question that you need to ask. And university math teaching today is premised on those beliefs about superiority, which were once explicitly stated in racist terms. So let's take the classic history of math by Rouse Ball, who's a professor at Oxford and so on. So he says that the history of mathematics cannot with certainty be traced back to any school or period before that of the Greeks. Alright? And though all early races knew something of numeration and rules of, they were neither deduced from nor did they constitute any part of science. That is their such an image. So they did something, some primitive stuff. And what was done with the Greeks and what was done with the West, that was the real mathematics. And that is what you should learn. Therefore, that ought to be universal. And this is, well, let's analyze these racist beliefs. They are founded on myths and dogmas of the crusading church. Because racism develops from there. I have a separate thesis on that. We will discuss it maybe during the discussion. So what are these myths and dogmas? First myth, there was a Greek called Euclid. You heard of Euclid? Must have heard of him. Did some geometry and so on, invented geometry, the famous Greek, supposedly. Another myth, that the Greeks did geometry differently. They used the axiomatic method and they had deductive proofs, and those deductive proofs are found in Euclid's book called the Elements. That's the myth. And there is a superstition that pure deductive proof based on reasoning is superior to empirical proof. So this is an empirical proof, 1 plus 1 equal to 2, that's an empirical proof. You're seeing something that you see is empirical. An axiomatic proof, you'll try to prove it from axioms, the way Russell and Whitehead do, and you'll take 378 pages. And you don't know what conclusion you have reached. So these myths and this superstition, by the way, is related to the church, crusading church dogma of reason. There's a Christian rational theology which started during the Crusades, and this is related to that. It was done by Aquinas and schoolmen. So let's dismantle these myths and superstitions and dogmas promoted by the church, which are contrary, of course, to original Christianity. They are contrary to common sense. So let us see what is the evidence for the existence of Euclid. Anybody here knows the evidence? Plenty of counter evidence that the book Elements was written by another person in another time for another reason. Alright? I have a price of USD 3,300 for serious evidence about Euclid. It is found in Indian school texts. There was this Euclid, he did this and so on, and I asked for the evidence. They have no evidence. So why do you need evidence? We have a committee, we go by the committee. Actually said that. Right? And so this is what we are trying to dismantle. So the last 7 years this price is standing. Nobody is able to claim it. And I think that that is a very serious problem. It's a problem of a major kind of fraud that is taking place. So this is one part of it. The other part of it, very simple. You have the book Elements. Whatever you consider to be the authentic version of the Elements, Heiberg's version, there are no pure deductive proofs in it. It is pure bunkum to say there are deductive proofs in it. It's a story which was spread for 700 years without the slightest evidence. The very first proposition in the Elements is empirical. And right to the last proposition, the penultimate proposition, the so-called Pythagorean theorem, is proved on the basis of empirical proofs. The fourth proposition, the so-called side-angle side theorem, is proved empirically, that is used to prove the so-called Pythagorean theorem. So there is not a single pure deductive proof in the entire book. It's a story. Contrary to the facts, contrary to the manifest facts. Just look at the book. You don't need to do anything more. Just look at it and try to understand it. Don't go by the story. Go by the facts. So this fact was admitted by the West 100 years ago. And Russell wrote, it's a scandal that Euclid is being taught. There are so many errors. He said errors. The story is right. There are errors. Euclid made errors. There was no Euclid. He doesn't have evidence. But you know, that was his intention. He didn't quite manage to achieve his intention. So it's a scandal that Euclid is still being taught in schools in Britain. And that scandal is persisting for the last 100 years. So what I would say is that the book was actually written in the 5th century CE, that is 800 years after the supposed date of Euclid, by a black woman. Why do you assume that all mathematicians must be men and that they should be white skinned? So this woman was from Africa, her default color is black. And in support of pagan religious beliefs, nothing about deductive proof. So this was based on Egyptian mystery geometry, that is where it is derived from. And it was appropriated by the crusading church through a process of reinterpretation. They are experts at reinterpretation. Give them anything, they can reinterpret it to mean anything else. So easy. And nothing to do with facts. It's all contrary to facts. So this is the woman, Hypatia, that's in the cover of my book, Euclid and Jesus, which also explains what has happened. And that thing burning in the background is the Library of Alexandria. And the fire burning in her eye is her soul. So this is, can you see the subtitle? It's about how and why the church changed mathematics and Christianity across two religious wars. So the two things go together. You'll wonder what it has to do, but it has everything to do with the church, because that is when Euclid came to be known during the Crusades to the West, around 1125 CE. Crusades were going on. So we have disposed of the myth that there were Greeks were there and the Greeks did something different. It is just totally false. Let's also dispose of the superstition. So what's the superstition? That science, you are taught and you believe, I think, that science is reliable because it's tested using experiments. Alright? You don't go by any metaphysics, you go by experiments. But math is the basis of science, that is also true. How do you do math? Superior way of doing math is to do it apart from empirical evidence. What a strange thing, it's just contrary to common sense. Why should introducing empirical facts affect math negatively? Especially if you are using it for science. But this is the belief. Take it away from facts, it becomes superior. So how does it become superior? It does not. So pure deductive reasoning, if you divorce it from the empirical, its inferior leads to invalid knowledge. So let's take an example. Pure deductive reasoning. All animals have two horns. Never mind, you know there are animals which don't have two horns. We are doing pure deductive reasoning. So pure deductive reasoning has nothing to do with the facts. Forget about the facts. Just look at the deductive reasoning. All animals have two horns. A rabbit is an animal. Therefore, a rabbit has two horns. They tell it to you in a different way, some Aristotelian syllogism that all men are mortal, Socrates was a man, so Socrates is mortal. Same format. And that is the formula for inference. That's how you deduce. But you know that the conclusion is nonsense. You know the conclusion is nonsense. It's invalid knowledge. So deductive proof can very easily lead to invalid knowledge if the starting premises are faulty. Alright, and how do you know that the premise is valid? You don't know in the case of present-day formal math. You start with the axioms of set theory. How can you test them empirically? They're all about the metaphysics of infinity. In fact, most of you won't know what it is. Most mathematicians won't know what the axioms of set theory are. I asked the head of the math department of one of our IITs. He didn't know. He could not define a set. And that is supposed to be the most prestigious institution in India. So, you cannot do that because the metaphysics of infinity that is involved in set theory creates a problem, and because it's metaphysics, you cannot test it empirically. No way you can test the metaphysics of infinity empirically. Okay? So, the claim that this kind of mathematics is superior knowledge is the claim that metaphysics which is based on Western authority you should accept it as superior. That's the claim. That's what you are being taught. And that's what is being rejected. Alright? So there are many other arguments about why deduction is bad. So deduction is more fallible than induction. Alright? Induction is fallible. I mean, your empirical proofs are fallible. Everybody accepts that. Okay? So, but what happens in the case of a deductive proof? So Euclid, the elements was kept as a model of deductive proof. Alright? And their very first proof in it was wrong. In case you want to know what it was, it's a very simple thing. You draw two arcs like that. You have a line segment and you draw two arcs. You measure this, draw one arc, and measure that, draw one arc, and then you join these two and show that you get an equilateral triangle. The point is, how do you know these two arcs intersect? You see them intersecting. But there is no axiom which tells you that they will intersect. If you think of these as arcs drawn on a computer screen, it's pixelated. So it may consist of dots like that, which just pass through each other without intersecting. You see it at high magnification, that's what you'll see. So it's an empirical proof. So very first thing is empirical proof, and people mistakenly thought it's a very good proof, a deductive proof. So you can mistake an invalid deductive proof for a valid deductive proof, and therefore deductive proofs are fallible. Alright? These are elementary proofs. But for 7 centuries, all the top Western scholars kept believing this. So think how badly you can go wrong. Right? Empirical proofs are fallible. Everybody admits the classical example in Indian philosophy is that you may mistake a snake for a rope or a rope for a snake. But can you do it for 7 centuries? You can't do that, right? You will just look around, you will see what it is. If the thing moves, then it's a snake, otherwise it's a rope. Right? That's quite straightforward. So you cannot make this sort of mistake for so long. Then there is a more fundamental problem about logic. On church dogma, logic bound God. So I have an article on that. It's actually from Islamic theology. You look at what Al-Ghazali said, and Al-Ghazali made a casual concession that God is bound by logic. But this became a dogma in the church. When it adopted Islamic rational theology, turned it into Christian rational theology. Logic binds God. Logic binds God, so logic is superior even to God. God cannot create any logical word, but he can create the facts of his choice. Therefore, logical proofs are superior to God, which is superior to facts, and therefore logic is superior to facts. That was the sort of thing that was used. So therefore logical proofs are superior. But you see, there are so many, logic is not universal. It's not culturally universal. It's not empirically universal. I mean, it is perfectly all right to say you have to decide it empirically, because it's all right. I might say that this pen is here and therefore it's not there. But it's not true for an electron. At the microscopic level, maybe it is here and maybe it is also there. Schrödinger's cat may be both alive and dead. And culturally, it is not universal. Forget about quantum mechanics. From the time of the Buddha, people have been using different logics. So there's a Buddhist logic of Chatushkoti, there is a Jain logic of Syazwad, and so on. And those are quasi-truth function logics. They may be similar to quantum logic. That's another story. I'm not going into that. I have done that in my papers. But the point is that logic is not universal. This was just a superstition, a Western superstition. So there are so many other things. Now let me just go quickly to the question of science. Church dogmas creep into science. How can they creep into science? Science is empirical, isn't it? Right? Not quite. So much of metaphysics. Imagine string theory. Now I'm not going to talk about string theory. I'll talk about very simple, down-to-earth science, Newtonian Physics. So Aquinas, in Summa Theologica, he said God is an ideal ruler, so he rules the world with laws. And since there is nothing like the nature of time in God, therefore those laws are eternal. So God rules the world with eternal laws of nature. This is what Aquinas said. He was quite sure. How do we know there are eternal laws of nature? Is that a scientific belief? Can you falsify it? Can you refute it? What can you do? Have you empirically found out that these laws are eternal? How can you find out something is eternal? Empirically. So we don't know. Every system of laws that we know, they have failed. But perhaps Aquinas knew. He went, met God, came back and said, this is the truth, I know that. Okay, so belief in laws of nature is rejected, by the way, by other cultures. Laws of nature is distinct from regularities, distinct from habit. So in Islam you have habits. I have another article in Islam and Science. You have accidents, ittafaq. In Hinduism you have reeth. In Buddhism you have paticca samuppat. So these are condition, co-origination. These are all distinct concepts. That's something the word co-originates, conditioned by the past, but not that it follows a law like evolution. You have some creativity, you can create the world, the fundamental difference. I will go into that maybe if somebody wants during question hour. I just want to illustrate that Newton's laws of motion are taught as the first lesson in science. Why do you call them laws? Just to spread church dogma? Newton wrote laws. He cancelled hypotheses in his notes and wrote let. In his notes, which were concealed because he was very against the church, but still he followed this. He wrote about how the Bible had been manipulated, and so Newton's work has been suppressed posthumously. But he cancelled hypothesis, wrote let, because he thought he had divine revelation that God had revealed his laws to him. So church dogma also creeps in. This is one example. Okay, now I can start analyzing Newtonian physics and show you what is all the metaphysics in it, what's the straight line and so on. But I'll just try to tell you that it creeps in a general way through mathematics. And for example, the laws of physics are formulated as differential equations using the calculus. The calculus involves a certain metaphysics of infinity. You have infinite series, you want to sum them. And well, that's the formalist misunderstanding of calculus. That's not the calculus. Let me correct myself. So to write down, how many of you here are mathematicians? Okay, So at least one. So I am not talking to an empty audience. Right. So if you want to write down the derivative with respect to time, then you must assume that time is like the real line, like the real numbers. Otherwise, the derivative does not make sense according to the calculus as it is taught today. And this again involves a dogma. It's a deep-seated dogma that you are assuming something superlinear time, which is contrary to quasi-cyclic time, which was very much part of early Christianity, Origen. But there was a politically motivated curse on that cyclic time, and this is a key aspect of post-Nicene church dogma. I discussed it in great detail in my book, 11 Pictures of Time. So once more, I'm just giving you a quick overview. I want to get on. So let me now, I've been talking about this, what has it got to do with colonialism? And colonialism, this is my definition, is con-olism. So this is a simple definition of colonialism. Why do I use this definition? Because colonialism, at least in India, was not established by force or by technological superiority. It was established by trickery. Alright? There was no military or technological superiority. How could there be a handful of people coming from across the seas without any proper knowledge even of navigation? But this trickery was achieved with the help of a key ally of the colonial state, which was the church. So Vasco da Gama came to India when 1498. And of course he came with the help of an Indian navigator. He didn't understand navigation. He didn't know latitude, longitude, how to determine it. Yes, he didn't know. He did not understand the technique used by the pilot, or which he calls navigator. The navigator used something called the kamal, and he was using the pole star. So pole star, the word for, he uses a strange language which is used by these people, which is called by the Mapilas. It's called Arabic Malayalam. It's a peculiar language. It's Malayalam, but it's written in Arabic. And he asked him, how are you navigating? He said, I am using cow. And cow means the pole star in Malayalam. It also means teeth. And the instrument is held between the teeth when you want to measure the altitude of the pole star. And so Vasco da Gama recorded the pilot was telling the distance by his teeth. Right? He actually recorded that. So he didn't understand. So he was brought, but anyway, the point is that in 1582, the Portuguese tried to conquer India by doing the Constantine. The way they got the Roman Empire, they tried to convert the Mughal Emperor Akbar, and they announced in Rome that, well, we are going to conquer India. The first military victory of the British came only as late as 1757. And that was not achieved by any kind of force. It was achieved by bribing the army, and the bribes were obtained from the Kolkata merchants by deceiving them. So they did not even put in the money, but anyway. So they were easily overthrown. The military rule was very insecure. In 1857, they were very easily overthrown. And but then they introduced this new weapon, and that was a master weapon, which was the university. The universities in India started in 1857. And this was not just a coincidence. They stabilized colonial power by inculcating loyalty. See, after all, they were ruling with the help of Indians. And if the Indians were not loyal, how could they rule? So to inculcate loyalty, they did that among the colonized. And the university was a church institution. Right from the time of the Crusades, when the first university was started in Bologna, the university has been a church institution. It has been a church monopoly. It remained a church monopoly until 1872 was the first bill for secular education in Britain. Now Macaulay, there were two things that he did, one something in 1835 and another speech that he made in British Parliament in 1847 against Marx. So Marx, it was about the same time as Marx wrote the Communist Manifesto and talked about a spectre haunting Europe. And Macaulay agreed with him. There's a spectre haunting Europe. He gives a very eloquent speech. There are a dozen fires blazing in London. Your predecessor sits trembling in his chair, afraid that the ruffians will beat down the door. And the Prime Minister's children are sent to the horse guards because that's the only, in their night clothes, because that's the only safe place for them. And so on. Then he says, you have this revolt, and then what did you do? You just went and hanged them. The state is not a hangman. It must prevent loss of property. Because the job of the state is to prevent loss of property. So that was his idea of what you would call classical economic theory. And so he said that you must educate them. Educate the poor, and that's the best way, the cheapest way of preventing revolt. Why? Because church education was started again during the Crusade. The universities were formed during the Crusade. Why? Because force did not work with the Muslims. And therefore, they said you have to convert them, you have to persuade them. In order to persuade them, you have to create an army of missionaries. So what do you do? What is the job description of a missionary? He has to have fanatical belief in the church. All things contrary to common sense, he must not only believe, he must propagate. And colonial education just changed slightly, that instead of the colonized mind, instead of being loyal to the church, was loyal to the West. Fanatically loyal to the West. And that's the kind of colonized mind that was created. And therefore, decolonization is the same thing as de-theologization. You de-theologize math, you de-theologize science, and that will also decolonize. Okay? Math and science both. So instead of using math and science to spread church dogma, the way Stephen Hawking, for example, does, we would like to eliminate church dogma and superstition from math and science. And that leads to something decolonized. That's the simple idea, and we can go into as much detail as you like because there's a vast amount of work that has been done on it. And of course, we also want to eliminate, let's not underestimate the power of myths. The church myths which are there in history and philosophy of science. We must eliminate those myths. Very important. So this has been done in the case of the calculus. The calculus, by the way, originated in India in the 5th century, not with Newton and Leibniz. That's just a false story. It developed over a 1,000-year period. And then it was taken, it was transmitted to Europe in the 16th century by Jesuits based in Cochin. They had started, first missionary school was started in 1508. It developed into a college which was then taken over by Jesuits around 1550. They went into mass translation mode. Just as they did in Toledo when they translated mass translated Arabic knowledge into Latin, they now mass translated Indian knowledge into Latin and sent it back to Rome. And among them were these tests, and this was needed. The calculus was used to derive very precise trigonometric values, precise to the 10th decimal place, to 10 decimal places. And these precise values were needed for the solution of the European navigational problem. The 3 dimensions to it: loxodromes, latitude, longitude. And the last problem was only solved in the 18th century. So Europeans understood the practical value of the infinite series, but they did not know how to sum it. So Descartes, you know the series for pi, which is called Leibniz series. So Descartes said that the ratios of curved and straight lines are beyond the human mind. Only God can sum them. That's the charitable interpretation of Descartes. Galileo said the same thing. Kepler didn't understand it. And as Newton said, Leibniz didn't understand it. And Newton himself didn't understand it. That is why his physics failed. He made a conceptual mistake in understanding it. But anyway, I don't want to go into that. It's a very long story. To cut a long story short, basically they added lots of metaphysics. Set theory, limits, real numbers, so-called real numbers. They don't really exist. All metaphysics of infinity. What's a real number? An equivalence class of Cauchy sequences. A Cauchy sequence is something infinite. Equivalence class is something bigger, infinity. So just one real number is a huge metaphysical structure with infinity. You can't write it down. So this is what we have. The point is, you eliminate that metaphysics, go back to the pre-colonial way of doing it, which by the way involved a very sophisticated sophisticated number system called a non-Archimedean number system, also involved a sophisticated philosophy of mathematics. So you go back to that, and that way the calculus can be taught in 5 days. That fact calculus text with 1300 pages, which so many people dread, it can be taught in 5 days, and I have demonstrated this in teaching experiments with 8 groups in 5 universities in 3 countries. So here are some of those groups. This is the group in the Central University of Tibetan Studies at Sarnath. This is the first experiment that was performed. This is the group in Tehran. And this is the group in Ambedkar University, Delhi. There are also other groups. I don't have photos of that, but this has been reported in various articles. So you can take a look at that. So usual doubt. How the calculus works? Oh, they have sent a man to the moon. So what do you do about it? They sent a man to the moon, haven't they? So the point is that there are 2 issues here. The first issue is that the practical thing is obtained in exactly the same way as it was done in the 5th century. When you send a man to the moon or you send a rocket, what you do is you calculate the trajectory on a computer. A computer cannot understand the metaphysics of infinity. It does not use the real number system, cannot use the real number system. It uses what are called floating point numbers. It works with finite numbers. Alright, and they don't constitute anything like that. When you say it's erroneous, doesn't matter. Point is the practical value is obtained in the same way. The metaphysics of infinity is irrelevant to the practical value. That's number one. Number two, if you eliminate the metaphysics of infinity, it works better. You get a better science. Okay, as in a better theory of gravitation. So Newtonian physics failed because he made a mistake about the calculus, therefore he made a mistake about time. He made time metaphysical. And if you correct it, then the correction leads to also a better theory of gravitation. So I have a number of papers on retarded gravitation theory. Again, I can show them to you, discuss them with you. I just want to mention it because I am giving an overview. And there is also a video and abstract of my talk at MIT. So you can take a look at that. That has all the references and so on, and all the details about non-Archimedean arithmetic, shock waves, non-standard analysis, whatever level of technicality you want to do it. And there is also an exposition of my own philosophy of science, which is based on pre-colonial philosophy, a philosophy of mathematics, and it's called Zeroism. And it is there in the Springer Encyclopedia and so on. There's also a conversation with the Dalai Lama. You can take a look at that. Let me go to the other point about the values of myth. So Macaulay, 1835, imposed colonial education by saying the West is immensely superior in science. Look at Copernicus. What did Copernicus do? He copied from Ibn Shatir of Damashq. Right? So the whole history is like that. Look at Claudius astronomy. It's all a creative text from the 12th century. Archimedes, you have things from 1800 years after him. So I've discussed that in some of my lectures in UNISA. You know this thing about Afrocentrism, and so I gave these lectures on history class of science in University of South Africa. So those things are online, you could take a look at that. But the point is that you must teach a decolonized history and philosophy of science as the first step. That's very important. And this is what I recommended in my book, Ending Academic Imperialism. So that's the thing, they make your brains like that, all uniform things like that. So you want to avoid that. And so what I said was, there was a curriculum development workshop, international workshop, and this course was taught to several batches of students. This is very small. This was the so this was done in Al-Bukhari University. This was the workshop, and these are the students of the first batch. I took them on an expedition to teach them how to measure the Earth. It's very simple. And Columbus had a wrong estimate, the West could not do it, and because the West could not do it, they had a problem of longitude which persisted until the 18th century. So just to teach them firsthand how easily it could be done. So this is Al-Bukhari University in Malaysia. And these are the students who are there at the, this was on, close to the day of equinox, and they are measuring the angle of dip of the horizon from a certain height. And they arrived at wrong figures, doesn't matter, they understood the principle, and you can always improve the technique. So there is a short video of the students' reaction to that course. I think I would it's just 2.5 minutes. So I would like to show that to you, especially since you have tested that the sound works.
Carl, you're from Cameroon, Somalia, the Gambia, Uganda.
I'm from Pakistan, Central Asia.
Ahmed Zawad from Yemen.
Eritrea, Kyrgyzstan.
Somaliland. From Mali.
Close to about 2 months now. 2 months?
Yeah.
And how do you find it?
I find it like it's very, very informative, because there are so many things I've come to realize that I have never known in my lifetime before.
The purpose of this course was just freeing our minds, telling us that the story that we have been told is maybe not totally true. There might be other sides of history also that has not been told to us.
Yeah, it has touched me, and I will feel like I need to dig deep into the part of philosophy and find out. Maybe there is more that is yet to be discovered and more what Africa has done than what actually knows.
So I think the course History and Philosophy of Science enlighten us to those gaps that couldn't be filled with our education system maybe, and also to acquire knowledge more about it.
He will give you, for example, the evidence, and you can apply it and see it by yourself. So you don't need much efforts to know whether it's true or not true.
Actually, the impact is not only in one thing, it was in so many things. Personality. Like, I cannot say there's one thing changed in my life. Like, so many things changed.
If there was a possibility for me to introduce my country, I would do that very much.
He did a lot, and what I can say now, my brains are washed.
Personally, I mean, without any exaggeration, I enjoyed this class more than any other classes.
Raju is really one of the most outstanding lecturers I've ever met.
He is perfect. Yeah.
That's a great A. But you're an A or A plus. As a student, you should continually assess your professors also.
I would give a star.
Okay. So that just gives you an idea of what happens, and I now just want to last 5 minutes spend some time on the counter reaction. How, if you try to push it into the mainstream, there is censorship and so on. So I had been to this happened with the South Africa editor of the Conversation. I had been to the University of South Africa and I had given a lecture on decolonizing math. And then somebody else published something on decolonizing math that was forwarded to me. And it said something very strange. It said that much, though certainly not all, mathematics was the work of dead white men. And therefore, if women and blacks are bad at mathematics, the right thing to do is to change their psyche, to make them think like the dead white men who invented the subject. So I responded to it, and the article went viral, and I just want to show that to you. I don't have it on the slides, but it is there on the website. So this is the article. To decolonize math, stand up to its false history and bad philosophy. So it is available on my website, where it's also available in Science 2.0, where in Wired, this is an Indian news portal, which published it, took it down and put it back with an apology. Another portal published it, took it down when Conversation took it down. And it exists also in Science 2.0, where he has ignored everything about philosophy and just looked at the issue of skin depth. Was Euclid a black woman? That's important, but that's not the only thing there. There's a lot of other stuff there. So it is still there, and you can take a look at that. And maybe I can just take you through this very quickly. That the point I made was that Rhind papyrus 3,700 years ago uses fractions. But there is no notion of fractions in Greek and Roman numerals. And fractions were first introduced into the Jesuit syllabus in 1572 by Flavius. And of course the Florentine merchants knew something. They had got it from Al-Khwarizmi's Hisab al-Hind. So what I asked was that what was the great mathematics that the dead white men invented when they could not even handle fractions? And the proof that they could not handle fractions is there in the calendar. I didn't go into it. There's also a video of mine on Tale of Two Calendars. The Julian calendar was wrong just because it got a wrong fraction for the duration of the year. And it got that because they had no means of even saying what the right fraction was, despite all those tall tales of Ptolemy. So I said that they have claimed, that Greeks did this and Greeks did that, and Pythagoras did geometry in a certain way, and there is no evidence for any of that. And the evidence that you have is contrary to that. that it was written in a different time, the book Elements, and therefore, as I said, it was written by a black woman, and the South African whites went mad. So they were very unhappy, they started abusing. They can give evidence, they can claim my prize. I did not stop them, I encouraged them to claim my prize, but they didn't want to claim the prize, they did not have any evidence. What they said was, simple thing we know we can abuse. So you can always abuse, anybody can abuse anybody at any time. All that it proves is the absence of strong arguments. Are you able to read this? I don't know if it will flow around, I can try. Are you able to read it now? No. Well, you read it on the website, I'll just read it out for you. Okay. So, this is about Euclid, and then as I said that people try to save the myth, they say we don't care about Euclid, we care about the book, but the book doesn't have deductive proofs, that's what I told you. And then deductive proofs doesn't lead to valid knowledge, they again went mad at the example of the rabbits having horns. Alright, that it's not, Pythagorean theorem is not valid for the curved surface of the earth and so on. And I'll come back to that issue in a minute. So, as I said, a mathematical theorem need not have any relation to the truth. It's pure fantasy. Alright, if it has a relation to the truth, it is purely accidental. And you have to start from valid premises to arrive at valid knowledge. And then I pointed out that by forcing people to believe in the axioms of mathematics which are formulated by the West, why do you believe in the axioms of set theory? Somebody formulated them, maybe Goldbach supports them and so on. So I said that this creates a slave mentality and this is the last thing we should do. And then I pointed out the successful alternative. There are so many newspaper articles on it, so much has been discussed. It was discussed a lot in Malaysia. There were 37 reactions and counter reactions when we brought this out, when we started talking about decolonization of mathematics. And they start off abusively, then they find that they don't have any facts to talk about. They say this happened, that happened, and say where are the facts? They don't have facts. So this has been discussed, it has been discussed in Iran, has been discussed in India and so on. And I mentioned these things. And I also mentioned this was the MIT lecture. And so this is what I did, and then this article was taken down. So article was taken down, we protested and so on. And then I'll just tell you what happened recently, that this article was published as part of this, after it was taken down, naturally I was upset, I was disturbed. Because if it was read by 17,000 people before it was taken down. So if there was something wrong in it, then the conversation should have pointed out what is wrong. They should have educated those 17,000 readers who were misled by me. But they could not say one single word except to abuse. Because anybody can abuse. What is that? So they did not correct it. They could not correct it. They knew they could not correct it. And therefore they took down the article. So this was the situation, and therefore I said that you must, because the situation in South Africa is very bad. You have decolonize, you have students fighting this battle for decolonization of the university. And they are fighting that battle because they, see, after apartheid, that ended only about 20 years ago. And after apartheid, they got access to the university but no success. And they suspect, and correctly, that this may be due to covert apartheid, which persists in the university. Covert racism which persists in the university, all the professors are still white, most of them are still white. And so they are agitating, and it's not enough to just, you must have heard about Rhodes Must Fall. Yes, so there is now a Rhodes Must Fall book coming out in Oxford in which this article is going to come. Because it didn't fall in Oxford, well, only in Cape Town, the statue of Rhodes. So this is coming out, and so I published the entire article as part of another article, which also explained the other part. Pythagorean theorem doesn't apply to the curved surface of the earth. People thought it's a triviality. It's not a triviality. The point is that Pythagorean calculation was not understood in the West until about the 17th century. So this is explained there, and this article is available for pre-download. It's online first article in Journal of Black Studies. It's available for pre-download and it's going to be published shortly. So I published in print. It's already there online. So you can download it and you can read it. I have taken 47 minutes. Thank you very much. I'd like to stop it.
Thank you for coming back. It's time for your contributions. So if you have a question, raise your hand. On my instruction, you will get the floor, and you can ask a question or make a remark. Let's see. Any questions? I will kick off then if you don't have a question yet. I wrote, I think, 17, so I'm surprised that none of you. Sorry?
We have questions.
You do?
I was a bit slow.
Oh, don't worry. It's a matter of shyness, so apologies. Yes, go ahead.
No, I mean, I was really wondering about strategies. How do you implement the decolonization of mathematics in faculties in university? How do you do that?
Yes, so we tried to do it at the level of the calculus. The reason to start at the level of the calculus was twofold. First, that calculus is the basis of science as it is done today. And second, if you do something at the university level, people don't get alarmed. The idea was that if you go down to the school level, people get alarmed. But the point is that the calculus apparently, well, I thought it was something very easy, simple and so on, but people seem to find that a bit complicated, a bit difficult. So now what I am doing, we are asking for strategy. So the strategy is to go to the level of the schools, 7th to 9th standard, which means approximately something like 11 to 12 to 15 years old, or maybe 12 to 16 years old, right? And I'm looking now at only one subject, geometry. And there I'm looking at Egyptian chord geometry and Indian Shulva Sutra, which are similar. So this is string geometry. So you're trying to write a textbook, not trying to, I'm writing a textbook on alternative math curriculum using string geometry. So the idea is that, let us say, if we look at Indian text today, NCERT text, if you like, I can show them to you just now. I have them on my computer. They will say a point is, sharpen your pencil, make a dot on a piece of paper, and that will give you an idea of a point. The real point is invisible. How can something invisible be real? You can't touch it, you can't smell it, you can't do anything with it. It's a real thing is invisible. Then the next year they will teach a point is something which cannot be described in words. So it goes on like that, and then in the 9th standard they will say that Euclid said a point is that which has no part, but he did not define what is part. So let us define part as something which has no area. But then what is area? Area means it is something enclosed by a curve. And so what is a curve? A curve is something made up of points. So what is a point? We are back to the starting point, right? So this is the kind of confusion that they sow in the minds of children. It is criminal. So this is what we are trying to change, that at this level, start changing things. Now the point of the string is that it has a great advantage over the compass box. You are taught with a geometry box. You took a geometry box to school, nice shiny new one, right? You must have taken it to school. I must have. Everybody does it. How could you escape a geometry box? If you go through school, you have to have that geometry box, or what you call it, maybe compass box or whatever. It has a scale and the protractor. You did it right. Just the words you are not getting across. Okay. So maybe you call it by a different name. All right. So that geometry box you took to school. Now that geometry box, how do you use it to measure a curved line? There is no instrument in it which can be used to measure a curved line. But the curved line is needed in order to talk about an angle. What is an angle? Open question. What is an angle? They teach in this Indian school text, an angle is something made by two intersecting lines. This is an angle. It's complete nonsense. You're talking about two straight lines, which are all metaphysical things made of infinitely many invisible points which are infinitesimally small. Right? So how do you measure the angle? Do you measure it here? Do you measure it here? Where do you measure? So they don't say, then people start saying, oh, you measure it right at the point. But there's nothing to measure, it's just a point. Right? So actually speaking, you measure it using a protractor. That's a semicircular thing. Why do you need a semicircle to measure an angle? They don't explain. What has a circle got to do with angle? Because an angle has nothing to do with straight lines. It's actually the arc of a circle. It is the relative length of the arc of a circle, relative to the circumference or relative to the radius. And how do you measure the arc of a circle? The arc of a circle is a curved line. So if you try to construct a protractor, you'll have to ask this question. If I take a big protractor, I take a small protractor, will it make a difference to the angle? It won't make. But that is a property of the circle. And that property is to be determined, at least you should know what is the length of an arc. And that you can only find out from a string or a cord, and this was the traditional way geometry was done. But today because the West used navigation tools and they went by straight lines, so you use everything in terms of straight lines. So this is the attempt that if you do that, it leads to conceptual clarity. And the problem, of course, is that although it leads to conceptual clarity, the students are otherwise thoroughly confused. It does not help them in getting marks in the examination. That's the purpose of colonial education. You must get marks in the examination, because that's how you're going to get a job and so on. But still, schools have agreed. The experiment is ongoing. Next month I will be carrying out, I've already spoken to teachers and students at the school level in various schools, tribal schools, the middle class schools and so on. And the idea is we'll be carrying out experiments and the students will understand that they are learning, but this will not help them to get better marks in the examination until the syllabus is changed. See, there is a collective solution. There is no individual solution, right? So that is the strategy that is now being tried out, that if we do that, and if we get the thing, because if you go and talk to the government, if I go and talk to the Minister for Education, very good, you have good suggestion, but he doesn't understand mathematics. He has a PhD in Hindi, so he cannot help me there. He has to ask somebody. Whom will he ask? He has to ask an expert. Who is an expert? Somebody who is authorized by the Colonize, maybe he has a PhD from Cambridge or Harvard, then he is an expert, right? So he has a problem. And previous minister, in fact, was only, past high school or something. She was not even educated. How could you make out there's a problem? So people don't understand. And even if they are sympathetic, they will say, oh, if you change the syllabus, then there may be chaos. That's what an MP told me. So you have to persuade them by saying that this experiment has already been performed. Here is an alternative text. We have done it with so many people, and now you must try it out. And that's the strategy, short. And we would also like to try it in South Africa. We would like to try it in the US, and so on. Right? May I sit here?
Thank you. Questions? Other questions? Yes.
Yes. I've been reading a lot about how Asians are supposed to be very good at math compared to non-Asians. And I've seen some documentaries about how math is taught in, for example, in China. And have you ever looked into the relationship between this talent then for math that Asians stereotypically seem to have, and the way that math is taught in countries like China and India? Is that already a bit more decolonized than the way it is taught here?
No. I don't know about China. I have not really studied it. But my sense is that the Chinese are more colonized than the Indians. More westernized at least than the Indians. That's my sense. And I think the Indians are very, very colonized. They are just copying this. And even when they try to change, they don't know exactly how to change. But they are open to the possibility. So I don't know about the talent for math. I think that ultimately, if you teach it properly, if you have the right subject to teach, it's not the fault of the teacher, it's not the fault of the students that they don't understand mathematics. It is the fault of the subject. If you say a point is something invisible to a 6th standard student, I cannot define it in words. How on earth do you expect him to understand? Him or her to understand? Cannot understand. So you have to teach it empirically. Here is a dot on the piece of paper. If you make a big dot, all right, that will also work. If you make a small dot, a tinier dot, that might work better, because when you are measuring the distance, it will work better. But you can see it, the dot on the paper. You can measure the distance. What we teach is something called Hilbert's synthetic geometry, where distance measurement is not allowed. You talk of congruence. And area measurement is still allowed. You can't define length, but you can define area. Wow, wonderful fantasy. And this is what is taught because the Yale Mathematics Study Group recommended it. So I do not know about the special talent for math, there is a certain calculation that is done. Calculations are done, they are done mentally. Maybe that's the reason, maybe the reason is cultural, that the Romans and Greeks were always bad at mathematics. So I cannot say, all right, what I can only say is that if you teach the subject, if you have a proper concept of the subject, it will work better. And people will automatically understand it, right? So I am not quite clear about there being a special talent among Asians or among Chinese, and I don't think the subject is taught differently. They do it exactly the same way as it is done in the West. Yale Mathematics Study Group said that let's do it the way Hilbert did it. It came in the US, 4 or 5 years later, it came everywhere in the Indian text. And it has been there since then. That's about 40 years, 45 years. So, right, it is very much colonized.
Thank you. I see you're warming up. So.
Yes.
Sorry, to respond to your question, apparently it's got something to do with Asian language, that the first 9 numbers are all one-syllable words, and therefore it's easier to learn how to count.
Could you please speak a little louder? I'm having difficulty in hearing you. Maybe if you have a mic.
With Asian language, where the first 9 numbers are all one-syllable words, which makes it much easier to learn to count.
Yes.
Do you think, what is your comment on that? So one of the reasons
I didn't hear it, I can't comment on it yet.
I will repeat it.
Yes.
One of the reasons why that might explain that Indians and Chinese have a talent for mathematics is that the first 9 numbers in these languages are all one-syllable words, and it makes it easier to count. Could that be one of the reasons?
Chinese.
I'm not sure that children necessarily learn arithmetic in their native tongues. If I look at my grandchild, I don't find that to be the case.
Yeah, and that is also a problem.
So I'm not sure, and I'm not sure that the fact that is being explained is actually a fact.
No,
maybe so.
This is also part of the thing, is that when you learn maths in the first year of maths, you learn how to write the numbers before you actually learn mathematical notation. So there's this like learning how to read and write and maths at the same time. I've got some background in maths textbooks.
Okay.
So, and there's always this emphasis in the way that they create those foundational maths textbooks in English and on writing out the entire word. And the complexity of that writing that word associates the complexity of the word.
Possible. I'm not saying that I'm just saying that so far as I'm concerned, I'm not sure that Asians have a special talent for math, that Chinese have a special talent for math. I'm not sure of that, and therefore, I mean, if it is the case, maybe you have a valid explanation, but I don't know about it. So I cannot comment on that in that sense.
Thank you.
All right?
Yes.
Yeah, I had a question, but I have to preface by saying that I'm not good in math. So I just came here because I found the title to be very interesting. Mm-hmm. But my question has to do with, in taking into account what we already know and what we have in schools right now, and your way of mathematics, how is your way better or more? I guess better would be the, for lack of a better word, the best than the ones that the curriculum that we already know and is being taught in universities.
Thanks.
Right. Now I can explain how it is better, but to understand the explanation, you need some knowledge of math. So it is a bit of a paradox. However, let me repeat the explanation that I gave. First of all, it makes it very simple. You see, you go to the way the calculus was actually discovered. Now all that is involved there is the basic rule of 3. Now what Aryabhat does is that he uses the rule of 3 to solve differential equations. Every problem of Newtonian physics is a problem of differential equations. It can be solved using the rule of 3. So it becomes extremely easy. You're not talking about infinitesimal, you're not talking about infinities and so on in that sense. You're talking about things that can be seen, that can be done. You're talking about approximation, which everybody understands, which is part of natural language. Therefore, it becomes so easy. that all the other formulae and the integral and the, all that sum and so on, all that is gone. And therefore it becomes so easy, because that's the way it historically developed. Think of how the fellow did it first. Instead of teaching the European misunderstanding. That's number one. When it becomes easy, you are able to do harder problems. So I have an example. If you take a look at my article, time, what is it that it can be measured? So it is also available on my website and you can download it. It was published by some Science and Education or something like that, some Springer journal. So there I gave the example with my own children. And this question cropped up because my children asked me this question: what is sine of 1 degree? Now how do I explain that without solving a differential equation? So I solved that equation. Then the question was, look at the first experiment that people perform is the experiment with a simple pendulum. And the thing written in the school text was that, well, you take the amplitude of the pendulum, release it from here, the time period will be the same. It's completely wrong. What the teacher had done was to memorize a formula t equal to 2 pi root over L by G. And then say, because the formula says this, therefore the time period will be the same. It is not the same, you can observe it. But then how do you calculate? To calculate it requires some advanced mathematics, something called Jacobian elliptic functions. So if you do it in the usual way, you will study Jacobian elliptic functions only later in life. Maybe as a graduate student in the 60s or 70s, they were still publishing handbooks of Jacobian elliptic functions. But if you do it as a numerical solution of differential equation, it's trivial, very easy. So you download my software Calcode, you can do it in a minute, not a minute, fraction of a second. Okay, a minute is too long. So you can do it in a fraction of a second, and it is extremely then easy, then you can compare. And my son did that project. And if you download Pendulum project, if you say what is the time period of a simple pendulum, exact time period, you can download it. He did it in school. So you are able to do harder problems. This is the simple part of it. The other part that I said is you are able to do better science. Because Newton did not understand the calculus, therefore he made time metaphysical. In his Principia, he uses 4 adjectives. Absolute, true, mathematical time flows on without regard to anything external. So it is metaphysical time. Why should time be metaphysical? Because he said that the laws of nature must be written in the perfect language of mathematics. God has written them, so he has written them in the perfect language which captures eternal truth. So how will it be perfect? If time flows by fits and starts, does something, there will be a problem. So therefore he had this theory of fluxions, time must flow smoothly. And that may not be the case in the real world. He says that you will not have any real clocks, actual clocks which measure that, but God knows, that's enough. Absolute, true, mathematical time, in God's mind it is there. But if you want to do physics, it has to be there in your mind. You have to be able to do it. And so he did not define equal intervals of time. But that is required in Newtonian physics. Because the first law will state, a body continues in its state of rest or uniform motion. What is uniform motion? Equal distances in equal times. Equal distances, let's say we know what they are. What are equal times? Can I take 1 hour from the past when I was talking, and 1 hour in the future when I will be sleeping, bring them together and say, now these two are equal. Right here I can see it. And do it, right? You have to define it. And he did not define it, and that is the reason why his physics failed. I have a book on that, Time Towards a Consistent Theory, which explains why Newtonian physics failed just because of this. So now if I want to do calculus, if I want to reformulate that physics, I have to also be able to do calculus in a different way. So as I said, it not only works, it works better in every way. But it is a little complicated to explain. It is also explained in my MIT talk, but it is technical. I am sorry I cannot explain it with absolutely no technicality. This is the best I can do.
So it makes it easier to solve harder problems, and it gives better science. And read the articles if you want to find out about the technicalities.
Right. Yes. And this is all published. You can take a look at it and read it and see what happens. Or try it out yourself. Do it, it's not hard. Alright, it's not hard. Learn the mathematics, it's very easy.
Yes, go ahead.
Yeah, maybe to continue on the question that the lady brought to the fore. you might have seen the movie on Ramanujan, this Indian mathematician who developed theories about infinite series. 1 plus 2 plus 3 plus 4 he developed the series in such a way based on formal mathematics, which means that you don't look at empirical truth, you just create axioms, definitions, propositions, and if you do that, you get the strange result that it ends up in minus 1. So how is it possible if you think with your logical mind, I get 1 cent plus 2 cents plus 3 cents, at the end of the day, I would be very rich, right? But here it says you will end up in debt, minus 1/12. So how is that possible that you get some outcome of math that is totally unrealistic? That is only possible because you can create fantasies with formulas. It's possible. So the question is not whether Indians have been able to create the fantasies as good as Western people. That is where the Eurocentrists judge the Indians. Do they do math as we did? What Raju is claiming, we did math better before they came. And the interesting thing is, if I've seen a lot of presentations of Raju, and what I liked, he didn't do it today, is how to show the way the Indians did mathematics without formulas. You can't think of mathematics without formula, right? X, Y, Z. But he shows you Sanskrit texts where they have the algorithm to do the square root of 2. Not in a formula, not even with a calculator. So if that was possible at that time, if you Google in YouTube Chinese math, you will see that they do arithmetic and multiply by lines, not by putting the numbers beneath. So the whole argument for decolonizing mathematics is that it acknowledges that Western mathematics created a system of fantasy that, based on the authority of the mathematicians, became known as science, while it was basically metaphysics. And before that, science was created, mathematics was created without a fantasy. And here is the interesting thing, is when we work together, the social sciences have the same thing. It created fantasies of the world, not based on the reality. We know about the discovery of the America, which was not a discovery, it was a fantasy, because people lived there. And so the social science is riddled with all these conceptions which are not empirical fallible, theoretically not fallible. And decolonizing science, and where the social science and natural science have this in common, that they get rid of fantasy and metaphysics, go back to empirical reality, take other logics than the two-value logic, true or false, in the Western philosophy, and then create a system of knowledge which is much more subtle and also plain to learn. And that's the challenge which is before us.
Is it possible to start a workshop with you here? Maybe can you come back here and teach us some of your methods?
Yes, I can do that. I have done that. And what I would like to do actually is to bring out a textbook on that, so that I am not, I become dispensable. Otherwise, I cannot go everywhere all the time and teach everything. But I can do that in one particular case. If you organize a workshop, I can come and demonstrate how easy it is. All right, to people who don't know math, provided they have done at least up to 8th standard or 7th standard math, they are able to add and multiply and so on. They know the rule of 3. You can explain everything else to them. It's very easy. I am willing to demonstrate that. And but I would like some help in preparing a text so that I don't have to keep demonstrating. All right. It takes 1 week each time. I would just like to add one small comment. The point that I made during the talk, one of the points I made, that the practical value of math. Now, I did not perhaps say, but The arithmetic algorithms you learn today, they actually came to Europe from India. I'm not saying that they originated there. Along trigonometry, algebra, calculus, probability, all this came to Europe from India. And it was misunderstood here. And what the point is that the practical value remains the same. That today, if I want to send a rocket to the moon, I have to calculate, not prove a theorem. Not say some axioms are there and I will prove a theorem. I have to calculate the trajectory of the rocket. And to calculate, I have to solve a differential equation, which is what was done. So the practical value remains the same. The metaphysics is irrelevant to the practical value. It has been added just to say, oh, we did something superior. And you don't understand it, so how will you deny it? Right? This is the trap. So that's all that I wanted to add, that the practical value remains the same, and it can be improved if you go back to the original philosophy, understand it, and do it better. That's what happens. It's true also for probability and statistics, and I have an article on that, Probability in Ancient India. It is published by some Elsevier Philosophy of Statistics. It's a series of volumes, Philosophy of Science, and volume 7, I think, is Philosophy of Statistics. So it is all there, you know. There is a very romantic story in the Mahabharata about Nal and Damayanti, and that is where you find this counting the number of fruits in a tree. It's applying statistics, because you have to do it using sampling theory. There is no other way to do it. It relates to the game of dice, which is a very old game. You find mention of it in the Mahabharata, in the Rig and so on. You find permutations and combinations. You find the binary expansion. You find binomial expansion. You find Pascal's triangle and so on. So please take a look at that article. There is also this fact book I have on calculus, on the origin of calculus in India and its transmission to Europe. It's called Cultural Foundations of Mathematics. So you can please take a look at that as well. So there is a whole huge amount of documentation. I can't just cover it in a few minutes or even a few hours. It will take a lot of time. Right, so it's all there. Please take a look.
Thank you. Maybe interesting also on the email list, it might be a good idea through the email list that we spread a link to one of those lectures in which you show how the Indians formulated, I use the word formulate, although I want to say without a formula, how they formulated the algorithm for calculating the square root of 2 or something.
Oh yeah, I can show it to you right now if you like. I probably have it somewhere. I could search it out. I can give you the source. But it may take me a couple of minutes to locate it.
While you're looking for this,
yes.
Maybe could. So what Raju is doing for Indian mathematics, the Africans doing of African mathematics. So you'll find in Africa, in the different universities, people who figure out how in Africa mathematics was developed. And like it is being done in Africa, we have people now in Latin America going to the cultures of the Maya, Aztecs, and the indigenous cultures there. And the same thing you see, that apparently there have been concepts developed without Western knowledge, which they built pyramid and which they did enormous technical inventions. So we wonder, if they did that without a formula, why not study it to see what we can use now? So that is one part of decolonizing math and science, that what we call is basically the reverse engineering, in the sense that you wonder how to build a pyramid without knowing anything about formal mathematics here. And then if you do that, you'll develop new concepts in math based on old concepts that have been developed already.
Maybe it's a good idea to move to other questions.
Okay, I just 2 minutes, I can just show it to you.
It's 2 minutes.
Since it's 2 minutes already, 3 minutes now. Okay, it's page 36, I'm almost there. And you can see the original since you asked for it, just to get a taste. So this is the Aryabhatiya of Aryabhat, where he explains how to get the square root. And the Babylonians also did it very accurately, square root of 2. It is also found in the Indian Shulba Sutra. But this is the algorithm which you learn today. It is the same as that. Page 36. It's going slowly. I think I have a fast computer. It is I7. It's 4 more pages. All right, area of a triangle. So here is this is cube roots, but the square root will be just before that. So this is square root. So page 37, this is page 36. So this is the verse which gives you the square root at top, and that is the explanation for the square root, and this is what you do, and here is an example of how you do it. So this is the original source. This is the first mention of an algorithm for square roots. The Babylonians had, but we don't, they calculated square root of 2 very accurately, but we don't know how they calculated. Right? So you find square roots in the Rhind papyrus also, but we don't know how in the Berlin papyrus, Berlin papyrus problems 1 and 2, but you don't know how it was done. No method is indicated. So this is the first documentation. I am not saying this is the first time it was done. This is the first documentation of how it was done, which is in the 5th century. It is a 5th century thing, and you know it is 5th century, it is not some fantasy about Greeks, because there is a continuous stream of text from that time to now. Various people writing commentaries and super commentaries and so on, in which they reproduce the original text in full, and so you can prepare a critical edition and you know that precisely this is what was said. So that's the formula for the square root. I have all the text with me, I have my books with me, whatever you want to see, it can all be shown. There is no problem about that. So I wanted to demonstrate that, right? Even if it took a few minutes. Thank you.
Thank you.
Yes.
You will demonstrate it?
This is here, it's there already, this is demonstrated. Yeah. Okay, so this is how it is done, and the algorithm is what you do, what you learn in school. Okay, there is nothing very difficult about it. So you are just taking odd places, even places, that is, you are doing it by 2, and then you are following the usual square root algorithm. So there is nothing very different. The only important point here is that this algorithm, if you apply it to square root of 2, say, it does not terminate. That's the important point. It does not terminate. And so that's the thing. It leads to an infinite series. In this case, you may find a square root, but if you apply it to, say, square root of 2, it leads to an infinite series, and you have to explain what that infinite series is. Right?
Thanks. A follow-up question to you.
If you want more details, I have that also. Yeah. But I think I gave the gist of it. It's all right. I don't want to get into more.
Follow-up question to your answer.
Yes.
You mentioned that we need to stand up to the false history of science that primarily shows the superiority of the Western scientific practice. In the video that you showed, we see students that say, we finally know now about the contributions of India, Africa, of the Muslims to science and the development of science.
Yes.
Why is this a relevant thing? Why is it relevant to say, well, it is important to see who wrote the book and do care about Euclid, regardless of the falsity or purported falsity of this book? Why is it relevant politically and socially?
Why is it relevant? So as I said, how was colonialism introduced? Colonialism involved colonial education. Macaulay in 1835, he argued, you see, the British wanted to introduce, they were funding colleges in Sanskrit and Arabic. And Indians said, why are you wasting your money on that? An Indian called Ram Mohan Roy was greatly celebrated. He said, why are you wasting that? We want to learn Western science. And looking at that, what Macaulay said was that 50% of the people in the council are with me. And he said that, one shelf of a European library is superior to all the literature of the Orient that you can find in Sanskrit, in Arabic, in this, that, and everything. He didn't even consider Africa. He didn't even consider Maya, he didn't even consider Inca, they did not exist for him. So, this is what he said. And therefore, because we are superior in science, in order to become superior, you must get science from us. Therefore, you must get Western education. And he slipped in church education. And that is the argument that is still given today. If you want technology, then you must get Western education because they have science and they have the technology. Actually, it's all the Indians who are doing the technology there. Whether it is Google, whether it is Microsoft, whether it's anything, they are the ones developing it. The ownership is somewhere else. So the person who invented the light bulb may have been black, but the ownership was with Edison. This is the kind of situation that you have. And so what he did was he brought in this. Now if you want to decolonize, you have to address that argument. And to address that argument, you have to point out that, look, here is what was done by China, here is what was done by India, here is what was done by all these people, and the history is false. The story of Copernicus glorifying him is false, the story of Euclid is false, the story of Archimedes is false, the story of Aristotle is false, and you have no evidence for it. But you have evidence for all this. So first of all, it restores the self-confidence. Afrocentrists like my friend Molapia Sante keep talking about it. And this is an important thing, that it restores your confidence, sense of confidence, because everybody, as Pitamaha has been saying, they feel inferior. It's not just Indians or Africans or Chinese, they all feel inferior. They're convinced that they're inferior. So you must get over that if people are to do anything. That's a very important thing. The morale has to be there. So if you want to fight a war, you have to have morale. That's just one part of it. The second part of it is that if you do it this way, it is better. Not only was it done there, it was done differently. So Copernicus, when he copies from Ibn Shatir, he makes mistakes. Newton, when he copies from calculus from India, he makes mistakes. And so on. That's the story. Even today, when the top mathematician of the world, Michael Atiyah, copies from me, plagiarizes 2 times, he makes mistakes. This is something which happens when 2 students in a class copies from one, copies from another. The one who copies makes mistakes. Even when you have mass copying and the answer is dictated, if you read the things, you'll find that people make mistakes, even while copying from a dictation. So this is what happens, and so you eliminate those mistakes and you do the things better. For example, calculus. You are able to do it better, more easily, you don't want all those complexities. So this is why it is important that if you want to decolonize, you want to change the system of education, you want to begin from there by countering Macaulay's argument that it is not that science developed in the West alone. It is not some kind of cultural superiority, that is false history, which glorifies the West unnecessarily. That is why it is important.
Thanks. Yes. Yes.
The question I have is, Professor, you're established. For me, as a PhD candidate student, it's quite difficult. I wanted to do my thesis on looking at Eastern African negotiation, conflict, negotiating after post-conflict. And every time I try to use an African scholar or some research that's been done in the country, I'm stopped by other professors, and they tell you we have some rules. You can have 10 scholars outside of the established in political science, so you need to change this. How can I still get these kind of scholars who know what happened, what kind of conflicts erupted, and what the history behind it is in my writing, and just get it through to be published, or to just finish my and get a degree?
Right. I sympathize with you. And I have also faced this problem, and I nearly got, didn't get my PhD nearly, because I had a quarrel with my guide, but I wouldn't advise that you do that. So what I would, I think this is a problem. One of my friends, Munir Pashe, he was in Harvard, and he wrote, he's a Palestinian, he lives in Palestine now, and he wrote his PhD thesis, in which he said he thanked his mother and the Palestinian hen. And Harvard went mad, said, you can't have this in your PhD thesis. Yeah. And as he says, why is such a big institution feels threatened by a mere inclusion of 2 references to his mother and the Palestinian hen? And anyway, it was a stalemate. Ultimately, he took the Palestinian hen out and let his mother remain. And this PhD thesis went through. What I would suggest is you finish your PhD. PhD is a point where you are particularly insecure, particularly dependent on 1 or 2 persons. Finish it whichever way you can, and then you will have a little more freedom to talk about it. Because if you want to fight, first of all, you must live to fight another day. All right? So do that, and then you will have the possibility to fight after you go become a teacher somewhere, or you have a job and so on. And you have the basis. If you stay in the West, you will always remain suppressed. Because you don't have the scope. I could do that because I come from a non-Western tradition, and I could reject it. I was trained in this tradition, I believed it myself, I taught it, but then I changed. And I was able to do that. And you will have to learn survival skills of guerrilla fighting. All right. So PhD is not the best time to do it.
Thank you. Just wait a little. We have time for one more question.
You have 17 more. No, we can stretch time a bit, you know. That's the decolonial view of time.
Decolonize.
Yes.
I think mine is more a comment than a question. I'm from South Africa, so a lot of the things that you've spoken about, I totally understand. The reactions, especially from the white South Africans, challenging their worldviews. I wish that I could be younger and I could be taught mathematics by you, because I went through
You can learn it at any age.
Of course, but it's been quite a sensitive topic for me, because I went through the government schools of South Africa, and I got taught colonial history, mathematics, English, Shakespeare, and I particularly struggled with mathematics because it wasn't taught to me in a way that I could understand. That I was told that these were the laws and you had to follow the laws. And I couldn't see patterns, I couldn't see how. And in my 12th grade, as you would say, I didn't think that I was going to make it, which meant I would not get admitted to a university. And I think, like, you know, if someone had taught me mathematics properly, maybe that's what I could have studied at university. So, I mean, I look forward to your textbook. Hopefully I can sit and go through it, and maybe mathematics I'll finally see the beauty of mathematics that everyone always
No. The beauty of mathematics is a Platonic concept. The idea that it's a Platonic concept. We are talking about its practical value.
Yeah.
Plato says you must teach mathematics because it arouses the soul. And that is where the beginning of metaphysics comes in. Right? That it arouses the soul like music. So that's a different concept. That's Egyptian mystery geometry.
Yeah.
So it does do something like that. I have no problem with that, but that's a separate thing. What I'm talking about here is a separate thing. I'm talking about practical value.
Yeah.
But it's easy, that makes it practical. Now I'm going back to South Africa to have a debate. I'm trying to have a debate. I have been trying to have a debate in India. I have been challenging people. Nobody is willing to come forward. That you people are teaching mathematics. Let school teachers, university teachers come forward and debate and explain why they are teaching the mathematics they are teaching. Can they justify it? And they are too scared to come and debate. However, in South Africa, they can't escape the debate so easily because it has become a very big movement. So I am going to University of Cape Town, I am going to University of Durban, and I will be at least they have said, we will have a conversation, if not a debate. All right? So we will have a conversation, whatever you call it, but debate is perhaps too threatening. But in India, we have been trying, other people have also been trying. There are people who run big companies and so on, but it is not possible apparently to do it. People are ducking. That itself tells you something. So I think that it is not really your fault, it's not the way mathematics is taught, it is what mathematics is taught. That is what has to change. If it changes, then it will be easy, the teachers will also understand, the students will also understand. Here neither of them understands.
Well, yeah. That's what it feels
So
like.
you can't blame yourself, don't blame your teachers, it's the subject which is at fault.
Thank you.
Please go ahead. Can we carry it on for another 5-10 minutes?
Decolonize my timekeeping.
Yes, that's time. This was Crescent's idea of a colonized time which goes by the clock. It's a mechanical clock. I just spoke about it in Berlin.
The reason why I'm tight on timekeeping is because sometimes people need to go.
No, if somebody wants to go, they can leave. Exactly. I won't consider it rude, but we can continue with the conversation.
If you need to leave, you
yes,
can.
If anybody needs
otherwise,
to leave,
we continue for 10 more minutes.
Yes.
Yeah,
right.
That's
okay.
I hope it's sufficiently decolonized now.
Yes.
Yes.
Fine. Thank you very much.
Yes. Yeah, in the back.
I have a question. I'm running late. But you mentioned some form of things the Western world didn't have.
Let's take the case of fractions. So as I said, there were no fractions in Roman numerals. Now the evidence for that, see, if you talk of text, late text, you can speculate and prove anything. But look at the robust non-textual evidence of the calendar. The calendar that was used in the West is the Julian calendar. And the Julian calendar was adopted by the Nicene Council as a Christian calendar. Now that calendar is wrong. What was wrong with it? It said that the length of the year, or the duration of the tropical year to be precise, is 365 and 1/4 day. Which is wrong. Which is horribly wrong even by the standards of the 5th century, even if they taught it to you in school, that it's 365 and 1/4 day. It is not. It's 365.242. But they could not say the so-called Almagest of Ptolemy, which was supposed to have been written in the 2nd century, does not have that figure. It has a better figure, but it was never used in the Roman calendar, never used in the Julian calendar. So that reform had to await till 1582. And then also they did not state the duration of the year as a precise fraction. They said leap years. All right, we will take every 100th year and not make it a leap year, but make every 1000th year a leap year. So that way you will subtract 0.01. But it was not stated in those terms because the decimal place value system, Simon Stevin introduced it in Europe only around 1570s. So they could not, 1580s after that. So they could not state it. So here is an example, robust non-textual evidence that the West could not manage fractions. One example. Longitude. Longitude, I have talked about the Pythagorean theorem in this paper. So maybe you could take a look at that. No, not this one. This paper. I've talked to the Pythagorean theorem. Why did the West have a longitude problem? So celestial navigation could be done by Indians and Arabs. And you find that Brahmagupta is talking about longitude calculation in the 7th century. And what he says is very interesting. He says that the Bhuvyasasya Agyanat Vyartham Deshantaram. So what he says is that in the absence of correct knowledge, or if you are ignorant of the radius of the earth, then it is futile to calculate longitude. Now he is criticizing his opponent Aryabhat. But the point is, if you don't know the radius of the earth correctly, you cannot calculate longitude from your latitude differences. And that is what the West did not know, because they did not know trigonometry. Clavius in 1608 published trigonometric tables from India to the precise to the 10 decimal places, but he did not know the radius of the earth. And that was calculated. That is what I showed you, that the students going and measuring the radius of the earth. So easy to do. If you know some trigonometry, and trigonometry is part of the Pythagorean theorem. Which Pythagorean calculation, which the West didn't have. So it was only in 1672 that they were able to calculate the radius of the earth. Descartes did that, but that was still not accepted because the sailors and so on didn't know it. Therefore you had to have a watch, a mechanical watch, the chronometer, which they give you the longitude. So these are two examples, and maybe you can look at more details there. All right? Thank you.
Yes.
To what extent do you think, because I completely follow the story that math can be improved and maybe there are different ways to do it, but there's also the thing, if let's say we improve the things in the university, what the institutional setting and value is going to be, because you also talked about that it's also practical, it's a practical way of doing things, but let's say we improve mathematics in the university, maybe we can improve, going to the moon and everything, but well, if we go back, I would wish that Europeans couldn't translate texts from India and the Arabics, because if they didn't have ships, maybe we wouldn't have, the ships going overseas. So, to what extent do you think, as decolonial mathematicians, we should also be engaged in discussions about what's then going to be the practical use of mathematics, because of the context in which it's going to be used?
I'm not sure I got your question, but I will try to answer it, and if the answer is off, then you please explain. You have agreed to ask the question again. So I think that what I'm trying to say is that this idea that West has a superior mathematics and science is the source of colonial power. Why is my article censored? Because if it comes out that the West made an ass of itself, you know, about Euclid, about the elements and so on, then their power is not going to look so good. Okay, so this is the critical issue. That, this is what, first of all, we are trying to change. Okay, we are trying to decolonize. The second part about what that it leads to better stuff. Why did Europe adopt so-called Arabic numerals? Because they gave a comparative advantage in terms of commerce. The Florentine merchants, first Pope Sylvester imported it from Cordoba, but he didn't understand it. The Florentine merchants imported it because it gave a comparative advantage in commerce. Fibonacci used to go, he went to Africa there and he learned. And he saw that you know, they are able to calculate quickly in their head and able to say something, and he is not able to respond, he's all the time juggling with his counters. So they changed it and they took it as a state secret, so well, their own secret, and they taught this algorithmus text from Al-Khwarizmi. Same thing is true for trigonometry. It came for the practical value for navigation. Same thing is true for calculus. It is true for a whole lot of science. It applies to a whole lot of science that you do. So all kinds of practical applications. Probability and statistics, whether it's gambling and dice, or whether it is you know, any kind of making any measurement with statistics, it applies across the board. The one difference that would arise is that you would include ethics. So when you are talking about statistics, for instance, today you find a whole lot of drugs. Oh, this is done like this is done like this, and after 10 years they will say there's something wrong with the trial. So knowledge is not something diverse from ethics. So statistician is not somebody who is paid for by the capitalist and says, okay, I'll do your dirty work for you and I'll do it, and that's science. And the scientist is not somebody who says, okay, I'll do your dirty work for you, I'll make a bomb and you drop it on anybody. That's not my moral problem. It is. So the ethics has to be included as part of, and this is there in all ancient traditions. You have to be ethical. Even economics. Kautilya does economics long before Adam Smith. He includes ethics in it. So you have to include ethics as part of knowledge. This would be one essential difference. Have I answered your question?
Yes.
Okay, thank you very much. Okay.
I wouldn't object to repeat it like it was answered. Yes. Next question.
I think it's quite a simple question. Oh, sorry.
Yes, go ahead.
Yeah, it's so. Is it that we're saying the West is wrong?
Of course. There's no doubt about it.
Okay.
Wrong in a number of ways. Wrong about the history, wrong about the understanding of calculus, wrong about science.
Yeah.
I'm saying that very clearly, and I'm giving you an alternative formulation for all those things. An alternative history of science, an alternative way to do mathematics, an alternative way to do science, in everything, not just gravitation, electrodynamics, quantum mechanics, and so on. So completely, there is an alternative formulation of physics. Right? I'm saying that very clearly.
Yeah.
Thank you. Okay. You have a question?
A short comment and then a question. As I understand, a lot of the mathematicians working at the beginning of the 20th century, Whitehead and
Russell,
went crazy, which I think is kind of empirical proof, or empirical evidence of the schism between Western mathematics and
you mean Whitehead went mad and therefore mathematics?
No, only Russell and Gödel and a whole bunch of
There's a whole lot of people. See, it's not just that. The Bourbaki group in France, they took it up and they brought out a whole series of texts, and that became the kind of Bible. This is what you have to use. This is the form of mathematics you have to do. I used it. I did it. I taught it. I taught formal mathematics for so many years in the university, and then finally I abandoned it. But that's a different story. That's the story that I'm telling you now. But that is how it catches on. You are indoctrinated into it from childhood, and then you start thinking about it. That's the right way to do it. And there's a whole peer group there which is doing that. So everybody is doing it. How could they all be wrong? But they are wrong.
What I was curious about is how you have integrated your work and stuff into computing, because apparently you just work with the
Could you please speak a little louder? I'm not able to hear you. Yes.
I'm curious about how you've integrated your work into your work on the quantum computer.
Into the work on the computer.
Supercomputer.
supercomputer. Well, actually it is because of the supercomputer, because I worked on it, that I got this idea. Because I went straight as a formal mathematician and left that and went to work on this. And then I employed some formal mathematicians. I gave them very high salaries, but they were not able to do anything. And then I wondered, what is this? If you want to solve a practical problem, you're not able to do all this stuff, is of no use. And what you are doing is something completely different, something completely very simple. And so then that is when I started wondering there is a problem with the formal mathematics that I learned. That's where the doubt arose. So normally a formal mathematician doesn't jump into the field of supercomputing and start doing it. But there was a practical problem to be done, it had to be solved, and their formal mathematics was completely useless. So that experience played into that, and then of course floating point numbers and this and that and so on, many other things came up. And then through what I was doing in physics, saw that what Newton has done is wrong in terms of his physics. So that also involved the calculus. So that is how, if you want my life story, that is what it is. You have 17 questions, you could ask one of them, maybe. You could be democratic and yes, I'm interested.
There's a question there, and there's a question there, and,
okay.
And at some point I will colonize your time.
Okay.
So I won't have that time.
No,
let's take these two questions and then we wrap up. So
just a short, maybe to finish on this, but we were just talking about your life story and how you turned into a mathematician, into maybe a more political person, a person more involved with your.
Well, I was always a political person.
And that allowed you to move into that area, maybe.
Yes. It allowed me in two ways. That first, because I was doing computers, I could afford to challenge formal mathematicians. Because I was not earning, my livelihood was not dependent on them, like you have this problem. So computers at that point of time, there was a big demand for computers and people who knew about computers. So I could earn my livelihood in a different way and then challenge mathematics. This book that I wrote on cultural foundations of mathematics, I wrote when I was in a computer science department. I was heading a computer science department. And not in the mathematics department, otherwise there would have been tremendous pressure. What are you doing and so on, how are you challenging? So that definitely helped. Right? So you should have alternative means of livelihood. So that helps, that you can fight a guerrilla walk where you are standing somewhere, you are fighting somewhere else. Otherwise you have a problem, right?
Thanks. Now we go to
mine, I don't know if mine is a bit repetitive, but it's kind of a move going on to her question,
yes.
In whether the mathematics that we know from here is wrong. Because in your seminar you kept saying that your way is better. So my question is better the opposite of wrong, or is your way is it because it's easier that it's better and right, or just because your way is better and the other way is just completely wrong?
Okay, so what I said, maybe I didn't get the message across. What I said was that there was a transmission. So let us say, for example, arithmetic, the algorithms. When it came to Europe, first time it came to Europe was in the 10th century with Gerber, who wrote a book on the abacus. He was the most learned person in Europe in mathematics. What he did was, he didn't understand. The reason you call them Arabic numerals is because he thought there is some magic in the shape of the numbers, which is not the case. So he had, for example, a position value. I mean, he understood that, but he did not understand that you need to do it differently. So he set up an abacus. Let me give you another example. Zero. Now, I'm not saying that Indians invented zero, but in Europe, zero came from India via Al-Khwarizmi's Hisab al-Hind. So the Florentine merchants, when they brought zero, they had a problem. Why? Because they had a particular way of doing things. The Roman numeral system is additive. If I write xii, it means 10 plus 1 plus 1. The place value system is not additive. If I write 120, it does not mean 1 plus 2 plus 0. Right? And so they were confused. So what is this 0? It has no value in itself, and it adds any amount of value to the preceding number. And contracts are manipulated. So if you have a contract for 120 euro, somebody adds another 3 zeros there, then you are sunk. So they passed a law that anything, any contract you enter in these strange Arabic numerals, you must write it also in words. And you still do that, you write checks, the instruments in words. So when you get it from some other culture, you don't understand it. Therefore, that misunderstanding led to the confusion, led to the inferior understanding of the calculus. Whereas the person who did it originally, he obviously had an understanding. You cannot create without understanding. Okay? Make myself clear? Thank you.
Thank you very much, Raju. Thanks.
Thank you.
I think that's very appropriate. We have to stop because at 10 we will be kicked out of the building. So that's one of the reasons why.
Very enough.
There are some remarks, some announcements that I would like to make before you are allowed to leave. First of all, some more comments on the organizations that brought you this event. The NUC, the New Urban Collective, is a network of students and young professionals from diverse backgrounds, primarily from African diaspora communities. The New Urban Collective is based in Amsterdam and focuses on decolonizing education, decolonizing the labor market, and anti-racism. The University of Color, UOC, is an intersectional group that emerged out of the Math House protests. The University of Color focuses on decolonizing the university. Critical Collective is an organization of volunteers that organizes events such as tonight's. The Decolonial International Network is a network of activists and academics who focus on decoloniality. It's not my handwriting. Decolonizing knowledge and practice. Is that well put? Okay. And I hope that these organizations, they decolonize so much that they at some point can decolonize time and security and not have them kick us out of here. One more remark on the New Urban Collective and on the University of Color. Both organizations contributed to the founding of the Diversity Committee of the University of Amsterdam. And I was asked to announce this as well. The University of Color organizes community gatherings that are open to everybody. UOC is not a formal organization, and everybody is invited on the 30th of March. When you join, you can also propose or take an initiative at the University of Color. Critical Collective organizes on the 28th, that's next Tuesday, an event about Islamophobia. It's in Dutch, and it will be in Studio K. So once again, thank you very much, Raju. And all of you, thank you for being here. I hope you have a pleasant evening.